Okay, so today we're going to look at the second half of solving trig equations. We're going to look at solving trig equations that have multiple angles. So we're looking at this right here. Solve the cosine of 3x equals to 1/2 by graphing. Okay, so here's the layout of the graph right here. I wanted to show you what's going on. So there's a couple of graphs overlaid in here so you can see it. The first off, the cosine of x, the parent function, is this big one right here. Okay, because this function has a period of 2 pi over 3, so it has compressed the cosine curve down by 1/3. And so what we see here in a multiple angle is it's affecting the stretches and shrinks of things, the period. So more answers occur more often, okay, but much quicker. So where I would normally have, for like when we did this problem before in the last video, where we have the cosine of x equals 1/2, we have one here at pi over 3, and another one at negative pi over 3. You can see in the same span that I have here, there are 3 answers in the same span as there is 1 answer here. So there are 1, 2, 3, 4, 5, 6 between negative pi and pi for the cosine of 3x to equal 1/2, and only 2 for the regular cosine curve. Okay, so there's 3 times as many answers in the same span as the other one. So we need to be able to do this algebraically to get all these answers so that we don't miss any. And so we're going to use the same process that we used before. We're just going to do one slight variation to it to get the multiple angle involved. Okay, how do we find all these algebraically? So let's just go through this process. I'll do the problem with you here. And so let's do this example. What is the cosine of 3x equals 1/2? How do I solve that? What am I going to do? Well, the first thing is you can do everything exactly the same way as we did before. Just think of this as the angle. Don't worry about that it's a 3x. Just the cosine of some angle equals 1/2. On the unit circle, because we always go to the unit circle next, where does that occur? When is the cosine of an angle equal to 1/2 in the unit circle? And we know already that's going to be at pi over 3, and the other one over here at 5 pi over 3. Okay? And so if we're going to do multiple angles, do all this, well, there is no way I can condense these into one rule. And the angle name is 3x, not x this time. So I simply write 3x is pi over 3 plus or minus. And then the next answer is 2 pi, right? Every time I go around the circle, I get another coterminal answer. So it'll be 2 pi times n. And the other one is 3x is the angle. And it's 5 pi over 3 plus or minus 2 pi n. So everything is exactly the same. The only difference here is this is not an x, it's a 3x, because that's the angle we were given. But I don't want 3 x's, I want to know what x is. I'm solving for x. So very easily, I'm just going to divide everything by 3. So when I do that, each of these becomes x equals, that divided by 3 is pi over 9. And this divided by 3 is 2 pi over 3 n, or 2 pi n divided by 3. See? And then this one right here, x equals 5 pi over 9 plus or minus 2 pi n over 3. And so those, and then n equals 0, 1, 2, dot, dot, dot. So these are my solutions to that equation. So it's all very similar to what we did before. Okay? Now, we also have it where we have it on an interval. So I'm going to do the same problem again, so I don't have to review. But this time, what would it be if the cosine of 3x equals 1/2 on the interval from 0 to 2 pi? So this one's a little bit more tricky because of the fact that I have to make a list. So everything is exactly the same. And so, but the difference is because now that is a multiple of 3, okay? the list I generated from this right here is pi over 3, 5 pi over 3. But because I have a 3x here, I have to go around and find all the coterminal answers 3 times around the circle. So 1 time around gives me these two. If I go around again, what are the coterminal angles that are associated with these? Well, 2 pi with a denominator of 3 would be 6 pi over 3. So add 6 to this, and I get 7 pi over 3. Add 6 to this is 11 pi over 3. Add 6 to that, 13 pi over 3. And then add 6 to that, it's 17 pi over 3. So this is once around the circle, twice around the circle, 3 times around the circle. This is for the angle 3x. So then to finish this out, to get the answers for x, all the angles in this interval that satisfy this condition, this equation, divide all of these numbers by 3. And so that's pi over 9, 5 pi over 9, 7 pi over 9, and so forth. So this is what you'll have to do for multiple angles on an interval. You have to then go around the circle that many times. You're going to go around the circle at least once, okay? And then this one's a 3, so we go around 3. If it was a 2, we'd go around twice. If it was a fraction, like a 1/2, we go around the circle once, okay? And then we get it, and we only take the answers that are in the interval. All right, so that's what I have written right here. And I'll just let you pause here for a moment, then you can write all that down when I have all those side notes and stuff. Okay, so let's continue on with some examples. So here's another example. This is going to be the tangent squared of x plus 3 times the tangent of x plus 1 equals 0. So we're going to find all the solutions to this one. So notice there is no interval. So I'm going to find them all with the plus or minus in pi stuff. And so I need to solve this. I can see clearly I cannot factor this. There are no factors of 1 that will add and give me a 3. I can't factor it. So if I can't factor this, I need to use the quadratic formula. So normally in the quadratic formula, it was 4ax squared plus bx plus c equals 0. Then the quadratic formula, then x equals a negative b plus or minus the square root b squared minus 4ac all over 2a. I know you all know this, but I'm writing it out anyway because I want you to see this is the quadratic formula for something of this format. Well, that's why we have an x equals out here. But I don't have an x equals out here. My x is the tangent of x. So when I use the quadratic formula, you need to keep in mind that it's not x equals, it's the tangent of x equals because the function is tangent here. And it'll be negative b plus or minus b squared minus 4ac all over 2a, and then plug in the numbers. So the coefficients in front of these things. So a is a 1, b is a 3, c is a 1. And we plug all these numbers into our problem. And then I get my two equations. I'll get the tangent of x is a negative 3 plus or minus the square root all over 2, and this is a 9 minus 4, which is 5. Okay? I can split this into the two equations that we want, so I have a tangent of x is a negative 3 plus the square root of 5 over 2, and I have the tangent of x is a negative 3 minus the square root of 5 over 2. A lot of times right now, because you want to know what quadrant you're in, you can use a calculator and get an approximate value here so you can figure out what quadrants you are in for these answers over here. But this is the exact part, so don't use a decimal in your response afterwards. So working this out and figuring that out, we can solve this for x using the inverse trig functions. Actually, we'll just forgot to do the circle first. So when working this out, this answer right here is going to be negative. The square root of 5 is like 2 point something. And so this minus 2 point something is going to be negative, and tangent is negative in quadrants 2, and 4. So that's what I have right there. Okay. This one over here is also negative, clearly. So it also has answers in quadrants 2 and 4. So how do I get x? Well, I solved this. I use the inverse trig function. The moment I use the inverse trig function, though, it is defined for only certain values, not all of them. So when I use my calculator and I get an answer for this, what answer is it giving me? Well, it is only giving me an answer. It will give me, because it's negative, it's going to give me this angle right here, but that angle is in quadrant 4 between negative pi over 2 and pi over 2. So it's going to give me a negative angle. Okay? And that's okay for this part, because all I need is an answer, and then I can add or subtract a pi to get to the next answer. So the calculator gives me this one, even though it's a negative angle, that's okay. And so this answer then can be written as x equals the inverse tangent of a negative 3 plus the square root of 5 over 2. And then where's the next answer? Well, the next answer is halfway across the circle from it, so you just go plus or minus n times pi. And that will generate both of those answers, and all the ones coterminal with it. The same thing applies over here. So x equals the inverse tangent of this quantity produces this angle right there. And it's okay to use that answer, even though it's a negative angle between negative pi over 2 and pi over 2. And so then I can write this answer as x equals the inverse tangent of this, and then plus or minus n pi or pi n, whatever it is. And then n is 0, 1, and 2. And so these then are my solutions to that equation. Okay? So if I don't have an interval, this is very straightforward. You just do the inverse function of whatever it is you have, and then just accordingly add or subtract some multiple so that you can get to the next answer. You don't need to worry about what the inverse trig function gives you. It's automatic because it's all coterminal, and so you're good to go. But the issue really arises is, what if I have to do something like this on a closed interval? And so that's where this gets a little tricky. So we're going to take the same problem. So now, what if you want the solutions in the interval 0 to 2 pi? What if I want that? Let's go back to what we had before. So we had this thing. We had our unit circle. We had these angles over here. And we found out that x equals the inverse tangent of a negative 3 plus the square root of 5 over 2. Okay? Now, since I'm on the interval, I can only have answers in this interval. If I type this in the calculator, it's going to give me a negative angle. It's going to give me this answer, but it's going to be a negative angle, and that negative angle is not in this interval because it goes from 0 to 2 pi. And a negative angle on a number line, a negative would be to the left of 0. So what I have to do is I have to keep that in mind, okay, that the inverse tangent is defined between negative pi over 2 and pi over 2. And then this part right here, 0 is here. I want my answers from here around, but this one only gives answers between here to here. See, this quadrant right here is not valid for us. So I have to take this answer and produce the two answers that I want in this interval. One of the answers is coterminal to this one time around the circle. So the one answer, the quadrant 4 answer, is this quantity right here. So your answer, your solution is going to be, because we're doing a list, your solution is going to be x equals the inverse tangent of this plus 2 pi. There's no n here. It's this answer, which is in between in quadrant 4 as a negative. I'm going to add 2 pi to it to get to the positive version in this interval. Now, how do I get to this answer? Well, it's this answer right here plus pi. So then I have this answer but plus pi. Because by doing that, this negative answer plus pi gives me an answer in this interval also in quadrant 2. So that's how that works. And we do the same thing on the other side for the other one. Remember, that one was the same, almost identical. You get quadrant answers over here. X was the inverse tangent of a negative 3 minus root 5 over 2. And again, that's in the wrong spot. And so I have to take this one and add a 2 pi for this one and add a pi to get that one. So then my solution would be x is the inverse tangent of this plus the 2 pi gives me the quadrant 4 angle. And then the same thing, the square root of 5 over 2 plus pi takes it from here to there and gets those two answers. And those are your solutions if I wanted to solve that same equation. If I wanted to solve this equation right here on an interval between 0 and 2 pi. Okay? So it's kind of tricky a little bit here, so you want to make sure that you ask questions if you get confused or something like that. I'm going to put this right here. This is what I had. I'm going to pause right here. This is the stuff you just took notes on. Sometimes I have little notations on the outside. So I pause right here. Write this out if you want. And then here's the bottom half down here where I just talked about on the interval. Okay. And so now I'm going to do a couple more examples for this video. So here's another example. This is illustrating some techniques that can be used. That's why I do these examples. What do I have? 3 times the secant squared of 2x equals 4. There's a lot of ways to solve this one. How would I solve this one? I would do this. First things first, isolate the trig function. So divide by 3. 2x is 4/3. Then I'm going to take the square root of both sides to undo the squaring here. And that gives me the secant of 2x is plus or minus the square root of 4/3, which when you simplify becomes 2 over the square root of 3. Okay. Now remember, the secant by identity is 1 over the cosine. So the 1 over the cosine of 2x is this. And so now I can do what? So this is the thing I wanted to show you. If I have a fraction equal to a fraction, even if it's a whole number over here, it's still a fraction, just put a 1 underneath it. I can flip both of them at the exact same moment, and I can get the cosine of 2x equals plus or minus the square root of 3 over 2. And it gets it into a format that uses the unit circle, which is where you want to be. Okay? You're only going to do problems that deal with sine, cosine, and tangent in solving these things at this stage in the game. So these are my 2 equations right here. Cosine of 2x is plus this, and this cosine of 2x is minus that. And so let's go to the unit circle. We can do them separately, or we can do them together. If I do them together, you'll see that I can condense these into lesser equations. So where is the cosine a positive square root of 3 over 2? Well, the cosine is the longer value. The x is the longer on the pi over 6. So pi over 6 is a positive one, and 11 pi over 6 is positive. But where's the negatives? Well, the negatives would be, one would be over here at 5 pi over 6, and the other one over here would be on this one at 7 pi over 6. And so what you notice is that I can pair those two up, and then I can pair those two up. So I don't need to have all 4. I can condense it down. So 2x is pi over 6 plus or minus pi n, pi to get to the one over here. And then for the other one, I start with this one. 2x is 5 pi over 6 plus or minus pi n. So from here to get to there. But I don't want 2x's. What do I want? I want to have it as just x. And so by dividing everything by 2, I end up with my solutions, which is x equals pi over 12, divide that by 2, plus or minus that divided by 2, and I get that right there. And then the other one would be x equals 5 pi over 12, plus or minus pi times n divided by 2, and n is your counter. And that produces all the solutions to this equation right there. And here's the last one I'm going to do for you guys in this video. 3 cotangent squared of x plus 4 times the cotangent of x minus 4 equals 0 on the closed interval 2 pi, 0 to 2 pi. Okay? So I see this as a quadratic. Hopefully you do too. We look to see if we can factor it, and we can. Factoring is always quicker than the quadratic formula. So you want to make sure that you try to factor things as much as possible. So 3 times 2 is 6. 2 times 1 is 2. So if I subtract the 2 from the 6, I get a positive 4. There's my two equations right there. So I know that the cotangent of x equals 2/3, or the cotangent of x equals -2. And again, I know on our calculators we can probably solve these, but I want you to switch it over to tangents. T is -2. So then I can flip both of these, and I get the tangent of x equals 3/2, or the tangent of x equals a -1/2. Remember, this is just a fraction, and just flip them both. So then I can do the unit circle with these two things. I'm on an interval here. The tangent is positive. So in the unit circle, the tangent is positive in those two quadrants. And if I look at this one over here, the tangent is negative. So I know that the tangent is negative in these two quadrants. For this one, the inverse tangent is positive, so it gives me this answer already in this interval. So there is no modification that I need to do. This is already in the interval. So this one will produce the two answers that I need. Is this is one of them, and the other one is pi away from it. So take that and add pi. So you have to pay attention to what you're doing. You just don't go through the motions, but understand that that answer is already in this interval, and the next answer just needs to be add pi to get the next one. But unlike this one over here is a negative, so the inverse tangent is going to be down here, not in that interval. Okay, because negative angles are not in here. Negative angles are on the this side on the number line. And so then to make the right answers, I just take this quantity, add 2 pi, and then to get this answer over here, take the same quantity that we have and just simply add a pi to it. So this is the one in quadrant 2. This is the one that's in quadrant 4. This one here is in Q2, and this one is in Q4, just so you know. Okay, so these are my answers that I'm going to get, and that gives you a couple of techniques and some things to think about as you go through all this process. And the reason why we switched to sines, cosines, and tangents is because we are more familiar with the unit circle technique with those angles than we are with the other trig ratios, which is why I want you to do it this way. Okay, If you have any questions about these, make sure you ask them in class. We'll go as many problems and examples as we can. And that ends this video.